Have you ever wondered what makes your smartphone smart or your computer tech? In this video, we'll be diving into the fascinating lore of ARM and x86 architectures.
Every single one of these devices has a chip inside that has the ARM CPU, and that ARM CPU is the brain of that device.
There's a company nearly every chip maker relies on that doesn't actually make anything tangible. Yet its blockbuster IPO in September valued it above $54 billion.
While these two design philosophies run the backbone of modern technology, we need to understand what makes them so unique and important in the grand view of everything. So, sit back, relax, and stay tuned as we uncover their history and reveal the stories that could change the way you see your devices. But first, we have to break down what CPU architecture is. A CPU, or Central Processing Unit, can be thought of as the brain of your computer. Its architecture controls how it processes instructions and spends energy, and it influences the performance and efficiency of smartphones, tablets, laptops, infotainment systems, smart fridges, and much more. But why do we only ever hear of ARM and x86 when talking about the hardware under the hood? To consumers, they are known as ARM and x86, but their official names would be CISC and RISC. If you watched part 1 of my Every Field OS That Could Have Been series, then the second name should be a callback, except this time we're not talking about an operating system, but a processor design. RISC stands for Reduced Instruction Set Computer, and its philosophy is centered around taking away as much complexity as possible from the CPU unless required. It is an innovation from CISC, which stands for Complex Instruction Set Computer. CISC uses large sets of complicated instructions with backward compatibility for decade-old software. It comes with a really dense codebase that's difficult to follow, but uses memory most efficiently. Being known for high performance, it's best used for applications requiring a high degree of parallel processing, which, in a nutshell, is a ton of processors and cores handling a complex task such as video editing or gaming, like a group project, but each member is actually focused. Intel's x86 chips use a CISC architecture, and the name x86 is a shorthand for the company's long lineup of chip models ending in those two digits. Intel's x86 architecture has become synonymous with personal computers and operating systems. Following CISC has proven optimal for tasks such as gaming, software development, design, and more. But that landscape is being disrupted with the rise of ARM architecture. What does it bring to the table?
Yeah, the quantum leap was from the last generation of Intel Macs to the first generation of Apple Silicon Macs. I've found myself recommending laptops to a few people. I had a friend ask me, well, I need to get a new laptop. What should I get? I recommended the M1 MacBook Air.
ARM architecture follows RISC, a design defined by its simplicity relative to CISC. It executes its instruction sets faster, optimized for low power consumption, making it an ideal choice for mobile platforms, whereas its performance and energy efficiency make it optimal for platforms such as supercomputers and embedded systems. Architectures that use RISC include ARM, PowerPC, Tricore, Coldfire, RISC-V, and more, but we really only need to know about the first. A small English company named Acorn, which you may remember from my OS series, favored the RISC philosophy and developed the Acorn RISC machine, which would later be renamed the Advanced RISC machine. When the company broke up, a semiconductor design company named ARM Limited was formed to license the ARM architecture to technology giants such as Apple, Qualcomm, Google, Samsung, and more. If you use a MacBook released after 2020, then you'd be using Apple Silicon, which is built on ARM architecture. If you use a Chromebook Plus model from a brand like Lenovo, then you rely on ARM. If you have a smartphone at all, you're likely using an ARM processor. But the game changer came in November 2020, when Apple shocked the world by proving there was more to ARM than meets the eye. At the start, Apple had licensed chips for its first devices, such as the Apple Computer and Newton PDA. It had relied on suppliers Motorola and Intel, and in 2008 it would go on to acquire PA Semiconductor, a California-based fabless manufacturer founded in 2003. By 2010, Apple had created the A4 chip for iPhones and iPads, and over time, the company had built experience for in-house chip design, which would culminate in the release of Apple Silicon for MacBooks, a total switch from Intel's processors. The M1 chip debuted on November 17th, over 5 years ago, and would go on to become a precursor to an entire generation of game-changing chips, with the M5 being the latest in line. Apple Silicon is an ARM-based system on a chip, a design where all the major components of a computer, such as the CPU, GPU, and RAM, are packed into one chip. Systems on a chip pack more efficiency into a smaller package. We can talk a lot about both power, performance, and efficiency of different chips, but you may be wondering, how are these figures measured exactly? When measuring the capability of a CPU, we generally have 5 categories to work with: clock speed, instructions per cycle, the number of cores and threads, its performance per watt, and benchmarks. You can think of clock speed as the number of cycles per second the CPU goes at for its cores. In each cycle, billions of transistors are actively working to get the processor through each step of executing an instruction. In other words, clock speed refers to the rate at which the CPU operates. But this brings us to the next metric, instructions per cycle. This would be the number of instructions the CPU's transistors get through at their clock speed, and this is, of course, supported by the number of cores and threads the processor has. A core is essentially just a mini processing unit, and a handful of these cores, typically 4 to 8, come together to form one greater processor. Each core runs at least one thread, one instruction. From this, we get the terms single-threaded and multi-threaded performance. With single-threaded performance, we're measuring the speed at which one core can execute a single instruction set. With multi-threaded performance, we're measuring the efficiency of a CPU in processing multiple threads simultaneously. Usually, single-threaded cores are ideal for more simply designed applications, such as older games, while multi-threaded cores are ideal for all the modern software we use, from browsers and game engines to word processors and simulations. Using humans as a metaphor, when you're single-threaded, you can ride a bike and listen to music, but not at the same time. When you're multi-threaded, you can do both simultaneously. All this requires a considerable bit of energy, which is where power efficiency, or performance per watt, comes in. It is a ratio that measures how much performance a processor delivers for every watt of energy consumed. We end this off with benchmarks, which are online comparisons between CPUs you can get from sources such as Geekbench. Now, what's the big idea? Or should I say, what's the big idea? While there are many CPU architectures out there, both ARM and x86 are the most optimal for today's digital devices. ARM is the design following the simplified RISC architecture owned by ARM Limited, who simply licenses it, while x86, created by Intel, follows the more complicated CISC architecture. ARM has proven best for smartphones, embedded systems, and other low-power devices, while x86 has proven to be optimal for larger tasks such as gaming, hence its popularity among personal computers. However, the story is changing with advances such as Apple's M series closing the gap between both architectures. But what do you think of all this drama? Are you against ARM architecture for PCs, or do you support it? Tell me down in the comments below, and smash that subscribe button while you're at it. Thanks for watching.